So to integrate this one, first we're going to take care of the denominator. Since we have a quadratic expression down, we're going to complete the square. We have x squared plus 4x plus 5. Since the coefficient of x squared is already a 1, meaning that we are going to move forward to dividing the coefficient of x by 2. So doing that, we are going to have x, then when you divide here 4 by 2, we get a 2. So we're going to add it, so it is going to be x plus 2 squared minus the square of it, which is 2 squared plus 5. Then after that, you are going to simplify. We're going to have x plus 2 squared minus 4 plus 5. Simplifying this further, we're going to have x plus 2 squared plus 1. So instead of having the whole lot of this expression here, we can simply replace it with this completed function. So putting back, we're going to have the integral with limits -1 and -2 of x over x plus 2 squared plus 1 dx. Now with this, using trigonometric substitution, I'm going to let x plus 2 be equal to tan theta, meaning that I can make x subject of formula. My x is going to be equal to tan theta minus 2. Finding dx for this one is going to be dx is equal to the derivative of tan is sec squared theta, then the derivative of -2 is 0, so this will be d theta. Replacing in our equation, we are going to have the integral from -2 to -1 of where there's x, we are going to put this expression, so it's going to be tan theta minus 2, then everything over where there is x plus 2, I'm going to put tan, so it will be tan squared theta, then plus 1. Where there is dx, I'm going to put sec squared, so it's going to be multiplied by sec squared theta d theta. With this, we can say our integral from -2 to -1 is going to be tan theta minus 2 multiplied by sec, everything multiplied by sec squared theta d theta. Then we divide this everything by tan squared plus 1 is sec squared. We know this identity. We know the identity that tan squared plus 1 squared is simply equal to sec squared theta. So instead of having this whole expression, we can replace with sec squared. So we're going to have sec squared theta here. Then we can see that the sec squared theta and the sec squared theta can cancel out. What will remain is the integral from -2 to -1 of tan theta minus 2 d theta. With this, I can split it, meaning that I can have the integral from -2 to -1 of tan theta minus the integral of 2 d theta. There's also a d theta here. So simplifying this, I'm going to have integral from -2 to -1 of sine theta over cos theta, then d theta, minus the integral of 2 with respect to theta is simply 2 theta. Then with this, we can say we let u be equal to cos theta, finding the derivative to this one, our du is going to be equal to negative sine theta d theta, meaning that where there is sine theta d theta, I can replace it with negative du. So writing our expression is going to give us the integral of 1 over cos theta, so negative 1 cos theta du. But since we said cos theta is equals to u, so this will be the negative, can take it outside, 1 over u du, then minus 2 theta. Then after this we can integrate this part, which is going to give us negative natural log of the absolute value of u, then plus minus u minus 2 theta. Then we said u is equals to cos theta, we can replace, meaning we are going to have negative natural log of cos theta minus 2 theta. But when you check nicely, our integral was given in the form of x and not theta, meaning that in this case we are supposed to change this theta word into an x word. To do that, we are going to say, since we said tan theta is equals to x plus 2, meaning that we can use a triangle, Pythagoras theorem, where we have here the hypotenuse, the opposite, and the adjacent. Now to this, since we know that tan theta is equals to opposite over adjacent, and here we can take it that our adjacent is 1, so we're going to have 1 here, then our opposite is x plus 2, meaning that we're supposed to find our c. To find our c, we're going to use Pythagoras theorem, where we say c squared is equals to 1 squared plus x plus 2 squared, meaning that our c is going to be equal to the square root of 1 plus x plus 2 squared. With this information, we can find our cos theta. So since this is our theta, meaning that our cos theta is going to be equal to adjacent over hypotenuse. Our adjacent for this one, cos theta, is going to be equal to 1 over, our hypotenuse is the square root of this, so it will be square root of 1 plus x plus 2 squared. With this, we can replace in our integral. Or before we do that, we can also find the value for theta. So we said tan theta is equals to this part, meaning that we can take the inverse of this function. So we're going to have theta, which will be equal to tan inverse of x plus 2. Now with this information, we can put in our in our function. So it's going to be negative natural log of the absolute value of where there is cos theta, we'll put 1 over square root of 1 plus x plus 2 squared, then minus 2, where there is theta, I'll put it tan inverse, so tan inverse of x plus 2. Now after that, we can simplify our work and put the limits. So applying the limit, since we are told that the limit is from negative 2 to negative 1, we are going to say negative natural log of the absolute value. I'm going to put the upper limit first, which is negative 1. So it's going to be absolute value of 1 over, when you put negative 1 where there is x, it's going to be negative 1 plus 2. So negative 1 plus 2 is giving us a 1. 1 squared is a 1. 1 plus 1 is going to give us a 2. So here we'll remain with the square root of 2. Then minus 2. When you put negative 1 where there's x, it's going to be negative 1 plus 2. Then when you add, it's going to give you a 1. Tan inverse of 1 is simply 90, which is pi, which is 2 multiplied by pi over 4. This will give us pi over 2. So instead of writing all this part here, we can simply replace it with pi over 4. So this is going to give us minus pi over 2. This is our upper limit. Then minus, we need to put our lower limit. So when you check for our lower limit, when you plug in the negative 2, which is here, you plug in where there is x, you put negative 2 here, it's going to be a 0. 0 squared is 0. 1 plus 0 is 1. Square root of 1 is 1. 1 over 1 is 1. Meaning that we are going to have negative natural log of 1. Then minus 2. When you put negative 2 here, it's going to be a 0. Tan inverse of 0 is simply 0. Meaning we are going to multiply this by a 0. So this whole lot of the lower limit is going to give us a 0. Then taking care of the upper limit, we're going to have negative natural log of distributing this, since we know it's a fraction using properties of logarithmics. We're going to have negative natural log of 1 minus natural log of square root of 2. With this, we can get a simplified division. So we have pi over 2 this side. Then here, when you punch here on your calculator, natural log of 1 is simply a 0. Then this negative and this negative is going to give us a positive. So we're going to have natural log of square root of 2. Then minus pi over 2. This one you can further simplify it as natural log of 2 to the power 1 over 2 minus pi over 2, where you can drop the power. You are going to have 1 over 2 natural log of 2 minus pi over 2 as our final answer.